Hey, how's it going, all you MRWC fans? This is Mr. Ainsworth, and we're going to get into Section 7 here, Part 1 in our class, and talk about some prerequisites here. We're going to be graphing functions throughout this unit, and we're going to be focusing on a lot of rational functions, so it's going to get a little technical pretty soon. But before we get there, let's talk about some basic families of functions here that you went over in Algebra 1 and also Algebra 2. So all of this is review. But we need to review it and get good at it and go over some basics. And what I'm also going to do is I'm going to incorporate Desmos. So this is all done by hand, okay? There's no calculator needed here. So now no calculator required, okay? Let me just say that as a caveat, okay? However, we are going to check with Desmos. And it's always nice to know if you guys get it right or not. All right, so even though there's no calculator required, all right, we're going to check with Desmos. And when we do that, we're going to set up an account, and you're going to be able to save your work throughout the chapter and throughout the section so you can use it later on, especially when it comes time to review. So you want to set up an account using your student email, using your student email address. Okay, and that should be a simple process right there, so make sure you do that, okay, because you want to save all your Desmos work. Okay, so just a little thing here, just a little plug in the beginning here. Good students, successful students, save all their work, save all their notes, and since we use Desmos a lot in this course, because it's a free online calculator, one of the best out there, it also is very useful as a study tool at the end of the unit or before a quiz or a test, because if you save all your work, you can just go back and review what you did, weeks prior. Okay, now our first section here, our first part, we want to review your first basic family of functions here called linear functions. So family number 1. Let's put it right here. So family number 1. It's called the linear family, okay? Linear functions. And I'm talking about functions that look like this. Y equals mx plus b. All right, they're all lines. They're linear, okay? Even the part of the word has a line within it, okay? These are straight line functions, or you look at their graph, they look like lines. They look like, straight lines. I don't know how else to say it. Some have positive slope, some have negative slope, some are horizontal, some are vertical. Let's go over all the basics. We know that m stands for the slope, okay? Rise over run, so this is rise, some vertical distance divided by the run. Okay, which is some horizontal distance. We call that the slope. Okay, so that's this coefficient here, the coefficient of x. And b, well, that's just your y-intercept, okay? B is your y-intercept where it crosses the y-axis. Okay, you started learning this in Algebra 1, nothing new. Okay, so family number 1 is the linear family. All of these functions here, 1 through 4, are linear. Okay, so when you compare the first function to y equals mx plus b, you'll see that the slope is 3/5 and the y-intercept is -3. So slope is equal to 3/5, which means you go up 3, right 4, from the y-intercept of -3, which as an ordered pair, it's 0, -3. That's called a y-intercept. Okay, so I'm going to be graphing them in blue. I don't know, just different colors here. I'll annotate in red, but I'll graph in blue just so you can see things better. So we start on the y-axis, the vertical one at -3. There's your y-intercept. Okay, 0 and -3, just drop down 3 units on the y-axis. And then from there, you're going to count up 3. So you go up 3, okay, and then right 5. So up 3, right 5, and you're here at 5, 0. And then you sketch your line, okay? Let's see if I can do that on the computer here. There we go. All right, and there's your linear function. So you're going to have to use slope here, guys, slope and y-intercept to graph these easily. Or you can develop a table of values. So the table is only used when necessary. Only used when necessary. You don't need it for a linear function. The more advanced way to do this is simply plot 2 points, draw a line. Plot the y-intercept, use your slope, graph the line. That's what you guys should have learned in Algebra 1. You did it extensively in Algebra 2. And hopefully that's easy for you guys. Okay, and you guys do number 2 on your own. Okay, so in this video here, I'm only going to do a few of them. And then you do number 2. And then when completed here, when finished, okay, when you're finished with number 2, so you can check with Desmos. Check with Desmos. Speaking of Desmos, let me go to Desmos right now. So I'm going to open up my browser. Okay, you type in desmos.com. I always put it at the top of the screen here so I have easy access by just clicking on it. You guys should have all of these, all the websites that you use on a regular basis, just put them at the top of your screen. So one click gets you there. Okay, like I can get to my scientific calculator with one click. I can get to all my important websites with one click. Okay, so let's see here. Now when you open up Desmos, this is default right here. They always default with this, so I don't need these functions here. So I'm going to delete them. Make sure you log in. Okay, you log into your account, and then you go up to the upper left and you give this one a title. So it makes sense to do, this is section 7. Section 7, prereqs, okay? Prerequisites, graphs. So prereqs, graphing, okay? So you save it. Now it has a title, so now you can save all your work. And if I ever ask you to submit your Desmos work, which I will, then you have a record of it right here. You can print this. Everything you generate you can print, which is kind of nice. Now we just graphed the function y is equal to 3/5, so 3 divided by 5. All right, and then times x. All right, plus, minus 3, so minus 3. So notice that, there's zoom. Try to adjust the scale. There we go. So notice that it has y-intercept at 3, negative 3, 0, negative 3. It intersects the x-axis at 5, 0. So what's cool about Desmos is that you can check the x and y intercepts. The y-intercept at 0, negative 3 is the same as our graph. See, right here at 0, negative 3. It intersects also on the x-axis at 5, or 5, 0. And if you look at Desmos here, it does the same thing. So you check everything that you do when it comes to graphing. Desmos will graph anything, and then hit the save button at the top, and you're keeping a record of all your work. So if I ever ask you to submit your Desmos work, which I will, now you guys know how to do it. Okay, so get used to this tool. It is used quite often, and we're going to be graphing heavily in this unit, and you have ability to check your work with Desmos. So the first one was called a linear function in what's called slope-intercept form. Okay, let me write that down. It's called slope-intercept form. Slope-intercept form. That's the famous y equals mx plus b. Number 2 is the same way. Number 3 is standard form. Now standard form is different. Notice that y is not isolated. Okay, the standard form is a times x plus b times y equals c. There's standard form. And note y is not isolated. So there's different ways to graph this. It's totally up to you how you graph it. Some people just use intercepts and use the intercept method. Okay, so for example, using intercepts, you can substitute 0 in for x and solve for y. So if you do that, 2 times 0 would be 0, and you get negative y equals negative 5, or 5. And then you put 0 in for y, and if you do that, you get 2x equals negative 5, so x equals negative 5 halves. And you can plot these 2 points and draw your line. So you could use intercepts if you want, or you can solve for y. Okay, so let's write that down. Solve for y. A lot of people, this is a very basic skill in Algebra 1 class. Okay, so let's review it. So 2x minus y equals negative 5, and let's solve for y. I'm going to subtract 2x first. I get negative y is equal to negative 2x minus 5, because 5 is negative. Divide everything through by negative 1, and that changes all the signs, and you get y is equal to 2x plus 5. Okay, if you divide all through by negative 1. And so now we know the slope is 2, so m is 2, or 2 over 1. The y-intercept is 5. So if you go to the graph and you plot the y-intercept at 5, and going up to, all right, going up to right 1, you're off the graph. So you reverse it. You go down to left 1, down to left 1, down to left 1, and you draw it from there. Okay? And so when you do that, what does it look like? Yeah, right about there. Okay? And that's how you can graph a linear function in standard form. All right, now let's check this with Desmos. Okay, and so let me minimize this and bring up Desmos. Let's put it side by side. So let's go ahead and go to the graph. So I'm going to deselect this one, and I'm going to enter the next one in, and I'm going to type in exactly what I am given. Okay, so not the new equation down below, y equals 2x plus 5, but I'm going to type in the original to see if I'm correct. Okay, so 2x minus y, all right, is equal to negative 5 minus 5. There we go. And then you just adjust the scale so you can see things better. You can zoom in and out if you like. And then what you guys should check are the x and y intercepts. So you click on these points. So notice that on the left here I have negative 5 halves, which is negative 2.5 comma 0. That's this point right here. This is your x-intercept. Okay, and notice that it jives with Desmos, and Desmos right here says negative 2.5 comma 0 as well. And notice that the line crosses the x-axis, okay, at that point. Okay, that's called an x-intercept. Now the y-intercept is up top here. The y-intercept, all right, is at 0 comma 5. So that's the y-intercept. And notice on Desmos it says the same thing, 0 comma 5. So Desmos will check your graphs and see if you're correct or not. So you got to learn how to use it effectively. And when you enter an equation in, just save it. And like I said, you can print all this work off here on Desmos. You can submit your work easily to me, which when I ask you guys to submit your work. And so get used to Desmos, because this tool right here is an awesome tool. Okay? All right, let's get back to the lesson here. Okay, so now you do number 4 on your own and check it with Desmos. Let's go to second family of functions. Okay, we're talking about second degree functions. So family number 2. Oops, if I can spell family here. So family number 2. These are called second degree functions because the exponent is 2, and they're called quadratics. Quadratics. And then the special name for them, you learned it in Algebra 1, and you did it also in Algebra 2. They're called parabolas, okay? The famous parabola, okay? It's called parabolas. These are the U-shaped functions that look like this, or they might open down like this. In Algebra 2, you saw functions that opened up left and right, too, so they could open up left and right. In Algebra 1, you saw ones that open up and down. In Algebra 2, you explored ones that open up left and right. All right, there's 4 different types of parabolas, okay, depending on the function. Okay, so here we go. The first one we're going to take a look at is something called vertex form, and vertex form is a times x minus h, quantity squared plus k. This is called vertex form. This hopefully is familiar to you because you learned it in Algebra 2. This is Algebra 2 review. Well, actually, you learned this in Algebra 1 as well. At least I teach it in my 9th graders, okay? So Algebra 1 and 2 review. So I know I teach this to 9th graders, so you've had to have seen this a while, okay? And they also get good at it in Algebra 2, because this is an important class of functions, especially in physics. Okay, so here we go. So just looking at the function, comparing things here. So the first thing I notice is that a is -1. Okay, so if a equals -1, that tells me that it opens down. Okay, it opens downward, so it looks like this. The next thing I notice is h and k. Now h comma k stands for your vertex. Okay, so you look at these two numbers here to get h, and then k is found by looking at the 3 right there. So k is 3 is pretty obvious. So h comma k is your vertex. What's not obvious is the h. So notice it says x plus 2 up top, and down below I said x minus h. H is the number such that if you subtract it from x, you get x plus 2. So in other words, x minus what number gives you positive 2? Okay, x minus what gives you x plus 2? And we know that x minus a -2 is the same thing as x plus 2, so h must be negative. So in this case, in this parabola here, h, your vertex here, the h value is -2, and then k should be obvious. K is 3 right here. So -2 comma 3. So we plot this first. You always plot the vertex first. So let's go left 2 and up 3. So left 2, up 3. And there's your vertex. Call it V for vertex. And then from there, it opens down. But what's the shape of it? Okay. Now, because a is -1, the parent function is y is equal to -1x, okay, squared. Okay, there's your parent function. We call this the parent. Okay, because this function that we're given is the offspring, it behaves like the parent, has the same shape as the parent, but it's just been shifted. Okay, the vertex of the parent function's been shifted over here 2 units left and 3 units up. So to figure out its shape and where you plot below this, you just enter in 2 or 3 numbers. Okay, so 0, 1, and 2. So then you evaluate it. So you substitute 0 into the parent function, negative x squared. So negative of 0 squared. What is that? Well, it's 0. 0 squared is 0. 0 times -1 is 0. And then you take negative of whatever 1 is squared. So you square the 1 to get 1, then make it negative, you get -1. And you take negative of whatever 2 is squared. So you square the 2 first. You always do exponents first, then make it negative. So you get -4. So you square first, then make it negative. Square first. All right, then multiply by -1. Okay, that's why these values are negative and not positive. The most common mistake people make is they square the -1. They square the negative, but that's not the case because the negative's not being squared, is only x's. So keep that in mind. So when you plot these values, you go 0, 0 you start from the vertex. So this is from the vertex. From the vertex. So you put your pencil at the vertex and you go right 0, down 0, okay? Or right 1, down 1. Right 2, down 4. From the vertex. Read in red, from the vertex. So put your pencil at the vertex, go right 1, down 1. Okay? And then you go right 2 from the vertex and then down 4. Okay? Right 2, 1, 2, 1, 2, 3, 4. And then you plot and reflect. Parabolas have what's called symmetry. And the symmetry, the line of symmetry, always runs to the vertex. So draw the line of symmetry here, like I'm doing, and then you reflect them. Okay, so this first point here, you reflect it on the other side. So go it's 1 unit on the right, so go 1 unit on the left. This point here is 2 units away from the axis of symmetry, so you got to go 2 units to the right, to the left, excuse me. So you reflect, and then after that you draw your famous parabola. And these points that we graphed better be on the graph. So what we're going to do now is we're going to check that graph with Desmos. So I'm going to go down to the third line here, and I'm going to type in your function. So y equals negative quantity, it says x plus 2, So you just type it in, and you square it. Deselect the previous one, so you're only looking at the parabola. Okay, so now you touch on the vertex. Desmos will give you the coordinates. Okay. Oops, I didn't type in the entire function. I got to add 3. And that now makes more sense. Okay. So the vertex is at -2, 3. That's what I said over here. I said the vertex is -2, 3. Well, the intercepts kind of hard to determine what they are in the graph. I mean, because they don't lie on the grid lines. So, but we can. Let me see. I don't know if we can do this or not. Let's see. We can plot other points. So let me see it. So at 0, -1. Ah, there we go. So 0, -1's on the graph. It is over here too. This is 0, -1 here. So it's on Desmos. We verified the vertex. We verified 0, 1. So our graph on paper is identical to the one in the graphing program. Okay, hit save. And there we go. So you can keep record of your work. So like I said, you're going to print this off and submit it. I'm going to show you what to do because all my other classes do that, and you're going to start doing that too, to prove that you're using Desmos, to prove that you know how to use the technology. All right, you're going to scan and submit your Desmos work. Let me write that down. So you're going to scan and submit Desmos work. Okay, so when you're doing that, when you're done with this, you just go up here to the share button, and then you hit print, and check this out. You can print it off, all your work, your functions and your graphs from Desmos, and then you just scan that with Adobe Scan, or just take a picture of it with the Adobe Scan and then submit it to me in Canvas. So submitting your work and showing that you're actually using the technology is easy to do. Okay, let's go. You can do number 6 on your own. Actually, you know what? Scratch that. We have to talk about one more thing. So number 6 is different here, because if you compare here, y is equal to a times x plus 4 squared plus 2. Notice right here a is 2. Okay, so I'm going to write that down. A equals 2. That tells me that my parent function is not x squared, it's 2x squared. Okay, so that's going to affect our shape. So let's get the, I didn't mean x plus 4, I meant x plus h. Fix that, guys, and then plus k. Sorry, I was supposed to write the general form here. So now we need to find the vertex. So let's focus in on this one here. So when you focus in on the vertex here, you got to determine h here, and then you got to determine k, what k is, by looking at the constant. So now remember, x minus a -4 gives you x plus 4. So h is -4 in this case. So I'm going to write down the vertex somewhere here. So right here, so the vertex is going to be -4 comma, well, k is 2. You're adding 2 to the function, so k is 2. So what you want to do is plot the vertex first. So go left 4 up 2. So you go left 4 up 2. There's your vertex. Put a V there for vertex. Now a is positive. All right, that tells me that it opens up. Okay, it looks like this. Some U-shaped function opening up. The question is, what's the shape of it? Okay, so you put in some values, 0, 1, and 2. So let's get the shape. So we gotta substitute these in the function. So 2 times 0 squared, well, that's 0. 2 times 1 squared. 1 squared is 1, times 2 is 2. 2 times 2 squared. You always evaluate exponents first, then multiply. Okay, exponents first, then multiply. Okay, make sure you follow the order of operations. So 2 times 2, or 2 squared, is 4, times 2 is 8. So what I need to do is I got to go right 1 up 2 from the vertex, right 2 up 8 from the vertex. So write down from vertex. Very important, just like I said on the previous problem. So put your pencil at the vertex and you go right 1 up 2. So right 1 up 2, plot a point. Now, before we reflect it, it'd be helpful if you draw the line of symmetry right through the vertex. So draw it as an imaginary dotted line. This is called the axis of symmetry. Okay, and then reflect it. So after I plotted the first point, I went right 1 up 2, and then you reflect it on the other side. 1 unit on the right, 1 unit on the left. You just reflect, that's all you do. Next point, you got to go 2 right, 8 up from the vertex. So put your pencil back at the vertex, count 1, 2 to the right, count up 8. 1, 2, 3, 4, 5, 6, 7, 8. After you plot it, you reflect it. And then you draw your curve. Okay, it's called a parabola or parabolic. This one's a little bit more narrow and steep because the A is 2 and not 1. Okay, so now let's check with Desmos. Go to your next function, deselect the previous one, enter the next one in. So y is equal to 2 times quantity x plus 4. And then you got to square that and then add 2. So hit the a squared button and then add 2. You have to adjust your scale by zooming out. Notice what I'm doing here. I'm adjusting the scale. Mine's a touch screen, so it's a little bit easier for me. You have to use the plus or minus buttons up here to adjust your scale. And let's see here. There we go. So let's check the vertex. Negative 4, 2. That jives with what I said earlier. Negative 4, 2. Now the y-intercept there is a 0, negative 34, and my graph on paper doesn't go up to 34, so you're not going to see the y-intercept on the paper. You can see other points though. See negative 2, 10 right there? See, oh, right there you go. And negative 2, 10 is already on the graph. It's right up here in red. Okay, negative 2, 10. So you can see that the graph is the same. All right, that's save it. Okay, and let's go on to the next one. All right, now that's vertex form. Family number 2, quadratics or parabolas in vertex form. Sometimes they're not in vertex form. So this is still quadratics, okay? But they're in standard form. Okay, y is equal to ax squared plus bx plus c. So, and again, when I say y, that's the same thing of f of x. Okay, so you've seen that before in algebra 2. Well, even in algebra 1, we start using what's called function notation. So y and f of x is the same thing. Okay, you read that as f of x. F of x, that's how you read it. You don't say f parentheses x, okay? You don't do that. You say f of x. And it's the same thing as y, so just get used to it. So that's y there. So y is equal to ax squared plus bx plus c. Now here if you compare, a is 2. And because that's positive, this opens up. Right away, you just look at the lead coefficient, and that tells you whether it opens up or down. Then you need to know how to graph it, and there's 2 ways to do it. You can get this in vertex form if you know how to complete the square, if you were taught that, and I teach that in algebra 1. Some teachers don't though. So if you had a teacher that didn't teach completing the square and all this, well then you have to do it the other way. There's another way you can find the vertex. Okay, so if you don't know how to complete the square, you find the vertex. And then you do what I did earlier. Okay, so the vertex is found by taking negative b divided by 2a. And everybody should have learned this in algebra 2 and in algebra 1. Okay, again, this is review. This is nothing new. So you got to put your values in. So what is the x coordinate of the vertex? Well, Here, b is negative 8. Just by looking at it, you see that b is negative 8 and c is 7. Okay, and a, like I said, a is 2. So a equals 2. So here we go. So negative b, which is negative 8, divided by 2 times b, 2 times a, which is 2. So let's simplify that. Negative of a negative is a positive, so 8 divided by 4, which is 2. And then you find y. So you find x first, and then you find y, and you do the same thing as you usually do. So you substitute it in. So every y value is 2 times whatever x squared is. So 2 times whatever x is squared, all right, minus 8 times whatever x is plus 7. So what I need to do is I need to substitute my 2 in here, and then evaluate. You've been doing this since Algebra 1 when you're in 8th or 9th grade. So the y value should be 2 times 2 squared minus 8 times 2 plus 7. So all I did right there is I substituted 2 in. You got to substitute. Okay? Substitute the value in here and here. And then you follow the order of operations. So here we go. 2 squared is 4, times 2 is 8. 8 times 2 is 10. 8 minus 10 is negative 2, plus 7 is 5. So when x is 2, y is 5. So my vertex in this problem is 2, comma 5. What happened here? What happened? What happened? Oh, Jesus. Okay. God, silly me. Why'd I put 10 there? I am a meatball. You can tell that I've been working too long. Okay, I need a break. 8 times 2 is 16. I just did a very, very silly mistake. Okay, I added in my mind and I didn't multiply. Shame on me. That's 16. Sorry, guys. Ainsworth is human. I don't know why I put 10. 8 times 2 is 16. 8 minus 16 is negative 8. And when you add 7, you get negative 1. So the vertex is not 2 comma 5, it's 2 comma negative 1. Okay, I just showed my humanness. Okay, but at least I checked my work there and I found my mistake and I fixed it. So there you go. Okay. Everybody makes mistakes. It's a question of learning from your mistakes and fixing them. Important lesson in life. Okay, so we're going to plot the vertex. So 2 comma negative 1. So just plot it, put a V there, draw your line of symmetry. Now, because a is 2, all right, because a is 2, that tells me the parent function is 2x squared. This is called your parent function. So the function that we're working on here has the same shape as this one. Offspring, or functions that behave like the parent, have the same shape. So when you hear language like that, when we talk about families of functions and parents and offspring, we understand that the offspring have the same qualities as the parents. And in this case, I'm talking about the same shape. So you just put a couple values in. 2 times 0 squared is 0. 2 times 1 squared is 1 times 2 is 2. And then 2 times 2 squared, that's 4 times 2, or 8. So from the vertex, and this is what I talked about on the previous page, we're going to go right 1 up 2. We're going to go right 2 up 8. So put your pencil at the vertex and go right 1 up 2, reflect it. And then you got to go right 2 up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then reflect it right over here. And then you draw your function, which in this case is called a parabola. And then you check it with Desmos. Okay, so let's do that. So deselect the previous one, enter the new one in. So y is equal to 2x squared. All right, plus, no, minus, sorry, go back, minus 8x, so minus 8x, and then a plus 7. So you just adjust your scale so you can see it. Okay, and if you put click on the vertex in Desmos here, it tells you that it should be 2 comma negative 1, which it is. That's what I calculated earlier. Okay, 2 comma negative 1, and you're good to go from there. And if you want to check the y-intercept, it's right here at 0, 7. Okay, and notice that I plotted a point right here that's at 0 comma 7. All right, that's called a y-intercept. So you can check points on the graph using Desmos and then save your work all the time, because you're going to be printing this off and submitting it to me anyways. All right, so keep record of your work with Desmos. All right, and then you can do number 8 on your own. Okay, now the next family of functions, the absolute value family of functions. So family 3. So this is our third family of functions that you should have studied in Algebra 2. All right, it's the absolute value function. Okay, now there's also a form to this as well. So the basic form is a times the absolute value of x minus h plus k, okay, where the vertex v is at h comma k again. Okay, that's called your vertex. And in this case, if you compare here, h is 1. So if you just look here, x minus 1, when you compare x minus h and x minus 1, obviously h is 1. So 1 comma something. And then here you're subtracting 3, so k is actually negative, so you get the vertex at 1 comma negative 3. And that's what you want to do, is you want to plot this. Okay? And then notice also, you don't see a coefficient in front of the absolute value, so I'm just going to put an imaginary 1 there. Okay? So a is actually 1. So when a is 1, that tells you the slope of the sides of the absolute value function. So that basically gives you an idea of the slope. Okay, so you plot your vertex first at 1, negative 3, so go right 1 down 3, put a v there, and then you use the slope on the right and the left sides of the function. When a is at 1, you not only know the slope, but you also know that it opens up as well. Okay, because it's positive. So this is positive. Okay, that tells you that it opens up. So you draw a portion of the absolute value function to the right, okay, with a slope of 1. So you go up 1, right 1, up 1, right 1, up 1, right 1. So that's the one portion of the absolute value function, and then you use the slope of negative 1 on the left side. So you go up 1, left 1, up 1, left 1, up 1, left 1. That's probably the easiest way you can graph an absolute value function. And then of course you want to check with Desmos, so let's do that. So let's type in the next one, deselect the previous one, type in the next one. So y is equal to the absolute value, okay, of x minus 1. So you just type it in, and notice that it gives you the same function here. So notice that the vertex is at, whoops, I forgot to finish the function. Forgot to type in minus 3. It'd be helpful. So now the vertex is at 1, negative 3 again. Notice it jives with mine. Okay, same vertex. Notice that it crosses the y-axis at 0, negative 2. So does this one on my paper. And then right here, this is at 4, 0. It's called an x-intercept. Okay, and look here, intersects at 4, 0, and on the left at negative 2, 0. So right here is the y, another x-intercept. It's got 2 x-intercepts, one at negative 2, 0, one at 4, 0. Okay, they're called x-intercepts because it's wherever the line or function meets the x-axis, you call them x-intercepts. 0, negative 2 is on the y-axis, so we call that a y-intercept. Just reviewing a lot of basic vocabulary here, guys. Okay, save that, keep that in Desmos. Okay, now number 10 is similar, but a is negative 1, so this one opens down. Okay, so keep that in mind. Okay, a equals negative 1, it opens down and not up, but it's the same idea. Okay, you do number 10 and check it with Desmos. Okay, now the next family of functions, we're talking about the exponential functions. So this is family, we're on family 4 here. These are exponential functions. Again, I went over these functions extensively in Algebra 1. All right, so you guys should have seen these. And you also should have seen them in Algebra 2. So this should all be review. This is called a function review. Prerequisites, okay? Nothing's new here. And if you didn't see this stuff, I don't know what happened in your class, okay? Because you should have gone through it. Because I know I teach it in Algebra 1, okay, with my 9th graders. We did all this work. Okay, here we go. So the basic function looks like y equals a times b to the x power. So notice the variable x is in the exponent. That's why they call these exponential functions. All right, plus some value k, let's say. All right, and b is called the base. Okay, x is your exponent, obviously. So in this case, our base is 2. This is base 2. Base 2. This next one on number 12 here, this one's base 3. So similar graphs, but one's steeper than the other, because the larger the base, the steeper the function is, because things increase very, very quickly when it comes to exponential functions. And that's where the name, when they talk about the virus nowadays, the COVID-19 virus, how it's increasing, or the number of cases is increasing exponentially, that means it's increasing extremely fast. Okay, and the best way to do this, guys, is to develop a table of values. Okay, so plot many points. Plot at least, I would say, 5 to 7 points. Okay, some positive, some negative. So I'm going to start off with some negative values. So negative 3, and then we'll get a value here, and then negative 2, and then negative 1, 0, 1, and 2, and so on. Okay, so here we go. Let's evaluate. So my function looks like 2, oops, I got it. 2, come on, Ainsworth, 2 to the power of x plus 2. So here I have to evaluate 2 to the negative 3 power plus 2. And that's equal to 1 over 2 cubed plus 2. Now 1 over 2 cubed, 2 to the third power, if you don't know your powers of 2, that's 2 times 2 times 2, which is 4 times 2, or 8. So this is actually 1/8 plus 2, or 2 and an eighth. 2 and 1/8. Okay? So my first order pair here, for my first point on the graph here, I gotta go left 3 and then up 2 and an eighth. So left 3, so right here is negative 3. Got to go left 3, let me put it in red here. Left 3 up 2 and a teeny bit more. Okay, right above the, 1/8 is small, right? If I divide that little unit up into 8 equal parts, okay, guys, 1/8 is not very much. So 2 and a 1/8 can be thought as 2 and a teeny bit. Okay, so you go left 3 up 2 and an eighth, 2 and a little bit more. Next one, I got to take 2 to the negative 2 power and then add 2. Okay, so what does that equal? Well, I got 1 over 2 squared, all right, plus 2, which is 1/4 plus 2, or 2 and a fourth. Okay, so I got to go left 2 up 2 and a quarter. So left 2 up 2 and a quarter. Next one, I got to take 2 to the negative 1 power plus 2. So that equals 1/2 plus 2, or 2 and a half. So my y values are increasing, they're getting bigger, because 2 and a fourth is bigger than 2 and an eighth, and 2 and a half is bigger than 2 and a quarter. All right, not by much though, but they are increasing. So I go left 1 up 2 and a half. So left 1 up 2 and a half, right about there, that's close. Okay, next one, 2 to the 0 power plus 2. 2 to the 0 power is 1. It's called the 0 power rule. And in general, any number to the 0 power is 1, with the exception of 0. Okay? So 2 to the 0 power is 1, plus 2 is 3. So I got to plot 0, 3. That's on the y-intercept right here. And then I got to take 2 to the first plus 2, and that's 2 plus 2, or 4. And then 2 squared plus 2, that's 4 plus 2 is 6. So I got to plot 1, 4, and then 2, 6. And then let's just do one more for funsies. So 3 here, and it's 2 cubed plus 8, or excuse me, 2 plus 2. and that's 8 plus 2 or 10, so I got to go right 3 up 10. So right 3 up 10, way up here. See, so the y values are increasing more and more. They're getting bigger and bigger faster. Okay, so when you graph this exponential here, it's a curve now. And it's going to increase really fast, so it shoots way up fast. Now, it doesn't ever get lower than 2. So there's something called a horizontal asymptote. This function has a horizontal asymptote at y equals 2. It'll never drop below that line. Okay? It's called a horizontal asymptote. Research it. Google that. Okay, and you'll see what I'm talking about. That shouldn't be anything new, though. I mean, you guys should know this stuff because you should have gone through it. So let me see. This one here, let's type it in. So y is equal to 2 to the x power plus 2. So 2, and use this a to the b button for your power. So you type in 2 to the x power. Got to hit the right arrow key to get out of the exponent before you add 2. Okay? And then notice it intersects at 0, 3 like it did with me. Alright, so this point represents your y-intercept here. Okay, at 0, 3. And then, let's see here. You can see, look at the graph. Look, see how fast it shoots up in the air? Okay? And the reason why it does that is because it's an exponential curve. They always do that. And look what happens to the graph. When you go to the left, way to the left here, the graph will never go below the line y equals 2. Let me type in y equals 2. See? The green one right here, it'll never dip below that. It'll get close to it, infinitely close in fact. Alright, but it won't go below that. And that's why we call it a horizontal asymptote. Okay, so man, this is a one hell of a review. Alright, so here we go. There's your exponential function. So this is an example of exponential growth. So when the base is bigger than 1, you have a growth function. So when the base is greater than 1, it's a growth function, or an increasing growth curve. Alright, when the base is less than 1, alright, it's called a decay function. Okay? Decay function. So it's decay or decreasing. And then we're going to experience that. So let's do, you guys do number 12 on your own. Let's do 13. This is the last one. Okay, so so the base is less than 1. It's equal to 1/2. So the base here in this one is 1/2. Alright, and you're going to see things get smaller and smaller and smaller. So let's pick some values. Let's start off with a negative value. So -2, and then get a value. I'll go to -1 all the way to 2. So -1, 0, 1, and 2. Okay, so let's evaluate this. So 1/2, use parentheses to the -2 power, and then -2. Well, 1/2 to the -2 power, the negative reciprocates this, so you get 2, and then you got to square it. And whatever that is, you got to subtract 2. So 4 minus 2 is 2. There's your first one. And then you got to take 1/2 to the -1 power and then -2. So the negative power reciprocates your fraction to get 2, and then you raise it to the power of 1 and then -2. And that's obviously 0. And then 1/2 to the 0 power, we talked about that earlier. We just talked about the 0 power rule. Okay, so this should be 1 minus 2 or -1. And then 1/2 to the first power -2 is just 1/2 minus 2, or -1.5. And then 1/2 to the second power -2 should give you 1/4 minus 2, and that's equal to -1 3/4. And you want to graph these. So you graph -2, 2, so -2, 2. And then you graph -1, 0. No. Okay, and then you graph 0, -1. There's your y-intercept. That's your y-intercept right here. And then 1, right 1, down 1.5. and then write to down 1 3/4. Write to down 1 3/4. And so your curve is a decreasing curve, a decay curve, and it's going down and not up because the base is less than 1. Okay. Now to verify everything I just said, let's type it in. So y equals, all right, use parentheses now, 1/2, so 1 divided by 2. And then you raise it to the x power. And then you have to use the right arrow key to get out of the exponent, and then you minus 2. And notice the x-intercept is at -1, 0, which is the case, and the y-intercept is 0, -1, which is the case. So these graphs match. And if you want to see that, you know, it flattens out, it'll never go below y equals -2, and you can prove that. You just type in y equals -2, and you'll see that horizontal asymptote. And so no matter how far you zoom out, no matter how big x is here, if you go cruise along the function here, it'll never go below -2. Okay, it's decreasing, and it's getting infinitely close to the horizontal asymptote, but it'll never dive below that. Not on this function. Save it, because you're going to submit this work. All right, okay, and then you do number 14. So there you go. There's a full review of everything you learned in these types of functions. Not everything, but a lot of what you learned in Algebra 1 and 2. All right, this is prerequisite skills. Nothing new here, guys. This is review. So go at your own speed. This is a video, obviously, so use it to your advantage, and pause, play, rewind, and use it to go at your own speed here. And again, use Desmos to check your work, and then when you're done, you're going to scan and print all your work in Desmos. So I'm going to just show that one more time. So you go, you save it here, and then you go to the share button and you press print, and it gives you all your work that you've done in the lesson right here. Okay, and it only is this is showing only page 1 of 2. There's a lot more. So on the next page here would be the rest of your work. Here, there it is right there. So those are all the functions. You can scan and submit this with your work. In fact, you know, let me do that. I'm going to print mine right now because that's what we do. And then include that when you submit your work in Canvas. Okay, guys, that's a full review from Ainsworth here. I'll see you in class. Bye-bye.